Hey y'all, how y'all doing? Hope y'all doing good. It's Dr. B. Dr. B teaches math. I'm glad you're here. Today we're going to talk about dividing polynomials. Now, if you've been following this lesson series, we've covered factoring polynomials, fundamental concepts of polynomials, add, subtract, multiply polynomials. Now we're going to be talking about dividing polynomials. So in this particular lesson here, I'm going to talk about what are factors, because I want to make sure I lay the foundation before we jump into big division. We're going to do a long division refresher, because I don't know about y'all, but how many of y'all haven't done long division in like forever, or maybe you need a refresh on the steps? Because when I was looking at it, I was like, oh, I don't even remember that. We're going to talk about for dividing polynomials specifically, we're going to talk about the long division doing polynomials, what the division algorithm is, synthetic division. I think you'll really like that. Some theorems that help you with putting all the pieces together, how when you divide and you get a remainder, how that relates back to the actual polynomial function itself. And of course, like always in all of my videos, some common mistakes and some key takeaways. Okay, so y'all ready? Let's get started. Okay, so what is a factor? Before we start dividing, I want to make sure that you understand the terminology of factor. So a factor is when a factor of a number is something that divides it evenly. For example, if you think of the number 8, 2 and 4 are factors of 8. Why? Because 8 divided by 2 is 4. There is no remainder. 8 divided by 4 is 2. There is no remainder. So 2 and 4 are in fact factors of 8. So that's why I put that it's a number that divides another number evenly. And when you divide, there is no remainder, or we would say the remainder is 0. So if you multiply two numbers together and you get that number, those two numbers are factors of that particular number. And you've seen this before, so let me show you. Let's do like, what are the factors of 12, right? So if I say, what are the factors of 12? What I'm saying is, what are the numbers that you multiply together to get 12? So we would say, okay, the factors of 12, we would say what, 1 times 12, right? Yeah. You would say 2 times 6. What about 3? Yeah. You would say 3 times 4. And then you would stop there, because as you notice, it goes 1, 2, 3, and then 4, and it goes up. So these numbers here, these are factors of 12, because when you multiply them together, they give you 12. Make sense? Now, if you're like, well, Ms. Dr. B, how did you find that out so quickly? If you're still learning your multiplication tables, what you do in your calculator, you would say, okay, 12 divided by 1. You get 12, the remainder is 0. So as long as there's no 12 point something, that means there's no remainder. Then do 12 divided by 2. You get 6. Then do 12 divided by 3. So you keep dividing those numbers until you get to 12, until if you always get a remainder of 0, then you would say that is a factor. So if you're still learning your multiplication tables, another thing that you'll notice, if you learn your multiplication tables, you'll be able to pull out all the numbers that will give you 12. But that takes time, that takes practice. Otherwise, it's just, okay, what two numbers do I multiply together to get 12? Look at 15. Now this is an odd number. Well, with 15, what numbers do you multiply together to get 15? Well, what? 1 times 15, right? And I'll even write it like multiplication. What about 2? Does 15 divide 2 evenly? If you take your calculator and you say 15 divided by 2, you're going to get 7.5. So that means it doesn't divide it evenly, because that 0.5 tells you there's a remainder. So 2 is not a factor. What about 3? Yep. 3 times 5 is 15. Anything else? 4? Nope. 6? Nope. 5, we already got 5, right? So then these would be all the factors of 15. It's the numbers that you multiply together to get 15. Those are called factors. Let's look at this one. So what are the factors of 36? So 36, well, 1 times 36, right? What about 2? Does 36 divide 2? Yes. 2 times 18. Okay. What about 3? 3 times 12. Good. What about 4? 4 times 9. Good. 5. Mm-mm. 6. Yep. 6 times 6 gives you 36. So look, these are all the factors of 36, because when I multiply them together, I get 36. Okay. these multiplied together give me 36. And look how many factors they have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are 10 factors, right? So again, it's the numbers when you multiply them together, they give you the number that you're looking at. Those are factors. And that means when I take 36 and I divide it by any of these factors, the remainder is going to be 0. It divides it evenly. Okay, divides it evenly. All right, look at this one. 105. Now again, you're probably like, okay, I don't know my multiplication like that. Bust out your calculator. Ain't nothing wrong with it. We know 1, right? 1 and 105. And you say, well, what about 2? Well, you have to say 105 divided by 2. We get 52.5. That means that 0.5 means there's a remainder, right? What about 105 divided by 3? Yep. 3 times 35. So you see that you can get it. 105 divided by 4. Nope. 105 divided by 5. You better know that one. 21, right? Because 5 times 2 is 10, and then 5 times the 1 is 5. Okay, what about 105 divided by 6? Nope. 105. Did I do that? No, divided by 6. Nope, because it's got a 0.5. 105 divided by 7. 15. 7 times 15. I'm thinking that's it. Yep. 105 divided. No, it ain't going to be 9. Oh. Ooh, and it ain't going to be this. Good. So it's not going to be 9. It's not going to be 10. So that's probably all the factors. And you're like, well, how do you know when to stop? Well, I'm looking at some of these numbers. So 15, that's 3 times 5, right? And then 21, that's 7 times 3. And then 35, that's 5 times 7. So I'm pretty sure we found them all. But these are all the factors of 105. So again, the factors are the numbers that you multiply together to get that number. It divides it evenly. The remainder is 0. We'll say there is no remainder. You say the remainder is 0. So when we start dividing these polynomials, it's going to be the exact same concept. You're going to be dividing polynomials and hoping you get a remainder of 0, because if you get a remainder of 0, that means that that polynomial that you divided it by is a factor. Okay, and I'm going to show you how when I'm saying factor here, it's the same factor when we get over here into polynomials. Okay, so that's why I say it's the same idea, the same concept. Now, long division. If it's been a minute, let's go on and go over this. Now, if you already know long division, you want to scooch on. But let's go over this. So now, that long division that you learned a long time ago when you write, you multiply, subtract, carry the number. We're talking about that long division, okay? So first, let's go over the pieces. Your dividend, that's the number being divided. So if I had 8, I'll go ahead and do it. 8 divided by 2, this is your dividend. It's the number that's being divided. This is your divisor. Your divisor is the number doing the dividing. Okay. So your dividend is the number that's being divided. Your divisor is the number that's doing the division. And then, of course, your quotient is the answer. And we know that 8 divided by 2 is 4. So that would be our quotient. I think that's going to run out. Yeah, quotient. Okay. 8 divided by 2 is 4. That's our quotient. So dividend, divisor, quotient. And then the remainder is anything left over. Now, if it's a factor, your remainder will be 0. But if it's not a factor, that's where the decimals come into play. So it's anything that's left over because the dividend was not evenly divided by the divisor. Now, I hope you're wondering, now why she got this burger here? This is what I use to remember division. Okay. When you eat your food, if it's really, really good, you eat the whole thing and there's no leftovers, right? So I'm the divisor and my food is the dividend. The divisor is dividing the dividend. I'm dividing my food up. I'm eating it all. And if there's nothing left over because it was that good, then that's my remainder. Now, if I have some leftovers, stuff I got to put back in the fridge, I didn't eat all of it, I got to take it back. That's your remainder. So that means me being the divisor, I didn't eat all of my food. And because I couldn't eat all of the food, or if it was too much or if it was too large, I'm going to have leftovers. The remainder is your leftovers. If the food's really good, you ain't going to have no leftovers. But if it was too much, you didn't like it, you couldn't eat it all, then that's when you'll have a remainder. Now, the way you can check yourself, and we'll do this, I'll show this to you, but your dividend is equal to the divisor times the quotient plus the remainder. So when we're looking at over here where we had the 8 divided by 2, if I take 2 and I multiply it by the 4, remember the quotient is your answer, I get the 8. So it's almost like you go this way, 8 divided by 2, and you get the 4. And then now you keep going. 2 times the 4 gives me the 8. Okay, y'all see that? So your dividend is what's being divided. Your divisor is doing the dividing. The quotient is your answer, and the remainder is anything left over if it did not divide evenly. Cool beans? Cool beans. So we're gonna do some examples because I know y'all might not remember long division. Okay, so let's do some examples. I'm checking my notes. I have 2 examples that we're gonna do. Okay, just so we can make sure we remember the steps. So let's see. We're gonna divide 1298 by 2, and then we're gonna list all the factors of 1298, just so you can see that they divide it. So let's see. I'm gonna use blue. Y'all remember how we wrote it? You would take your 2, right? And then you would say 1298 like that. Y'all remember? So remember, this is our dividend, the number being divided. This is our divisor, the number doing the divisor. Remember, your quotient ended up here, and then after, depending on how far down you go to your answer here, this was going to be your remainder. Y'all remember that? Y'all remember that? This is gonna be fun. Okay, so let's try it. So what you would do, you would say, okay, you would find the highest what do you call it? I'll say place value, or the highest number under here, and you would say, can 2 go into that particular number? So let's see. You're not gonna do 1, but can 2 divide 12? How many times can 2 go into 12? That's how we used to say it back in the day. But you would say 12 divided by 2 is what? Good. 6, right? So then that means 6 times 2 is 12, right? And then you would write this 12, and then what would you do? You draw this whole line, and you would subtract it, right? And then you would say, okay, 12 divided by 12, you would say that that's 0. And so then you would do what? Remember, we would bring down these numbers here. Y'all remember that? I'm saying remember that like I'm old. So we would bring that number down. My arrow's a little too long. So let's bring down the 9. So once we bring down the 9, we have this, right? And then you would say, sorry, bring down those numbers. And then you would say, okay, 2 goes into 9 how many times? 4, because 4 times 2 is 8. I can't go over the 9. That would be 2 times 5 is 10. So then you would say, okay, that's a 4. And then you would say, okay, 4 times the 2 gives me 8, right? And so then you would have your 8, and you would subtract. I probably wasn't supposed to bring that down. Y'all leave in the comments and let me know. I don't think I'm supposed to bring that down yet. And then you would say 9 minus 8, you would say is 1, right? Then we would bring down this 8 because that's our next digit. Let me make this shorter. We would bring down our 8. And then you would say, okay, 2 would go into 18 how many times? 9 times, because 9 times 2 is 18. So you would say 9 times 2 gives me 18. You would subtract that, and you would have a remainder of 0. Y'all remember that? Y'all are like, this is not nostalgic, Dr. B. I know that's right. Okay, so this was your remainder. Okay, this is your quotient, which is your answer. This is your dividend, the number being divided, right? And then this is your divisor. Y'all remember that? I hope y'all remember that. That's a fun back in the day thing. So what this essentially means because we got a remainder of 0, that means 2 is a factor of 649. Matter of fact, let's list all the factors of 649, not 649. I said that wrong. 2, because the remainder is 0, 2 is a factor of 1298. 2 times 649 gives me 1298. So that means 649 is also a factor. I said that wrong. So if I were to list all the factors of 649, I'll write it over here. Why do I keep saying 649? If I were to list all the factors of 1298, what would that be? And I'll write them going down. Well, we know it's 1 times 1298, right? And now we know it's 2 times 649. And then you'd say, okay, well, what about 3? So do 1298 divided by 3. And it's like, nope, doesn't work. 1298 divided by 4. Nope, you're going to keep going. And then it looks like the next factor, I'm looking at my notes, is 11 times 118. 1298 divided by 18. Yep, okay. 1298 divided by 9. Yeah, you'd have to keep going. And then the last one looks like is 22 and 59. Those are all the factors of 1298. That means that if I take 1298 and I divide it by all of these numbers here, I should get a remainder of 0. Okay, let's do another one. 945. Woo, 945 divided by 5. So you would say, okay, how many times does 5 go into 9? 5 would go into 9 how many times? One time? You would say 1 times 5 is 5. 1 times 5 is 5. And then you would subtract it, right? And you would get 9 minus 5, you would get 4. And you're left, and you bring down the next number, right? Okay, and then you would say 5 goes into 44 how many times? Well, 9 times 5 is 45, so that's too high, so it would go into it 8 times. And so you would say 8 times 5 is 40, right? You would subtract it, and 44 minus 40, that gives me a 4, right? And then you would bring down this number, which is the 5, and you would say, okay, 5 goes into 45 how many times? Good, 9 times. And you would say 9 times 5 is 45. You would subtract this, and then you would have a remainder of 0. So that means that when 945 is divided by 5, I get 189. That means 189 times 5 is 945. And because I have a remainder of 0, that means it divides it evenly. Now, let me give you all the factors of 945. I have them written down. So it's 1 times 945. I think it's 2 times 315. 5 times 189. 6 times, oh, not 6, 7. 7 times 135, and then 9 times 105, 15 times 63, 21 times 45, and then 27 times 35. Woo! So these are all the factors, okay? These are all the factors of 945. That means every single one of these numbers, when they divide 945, they divide evenly, and that means that it is a factor. Easy? Remember, at any point you can leave comments for your questions. So when we start dividing these polynomials, we're going to do the exact same thing. Now, the only way you can do, not the only way, you're going to do long division with these polynomials, but what you're going to be dividing are different types of polynomials. A lot of times you'll see like a trinomial divided by a binomial or a trinomial divided by a monomial, but I want to make sure that you see where I put it contains more than one term. So a monomial is a polynomial with one term. Okay, so you're not going to be in this. You don't like what am I trying to say? You don't have to go as far as doing long division when you're dividing by one term. You just do regular division. I hope that makes sense. But when it's more than two terms, so a polynomial with two terms, for example, like x squared plus 1 or x plus 1, see, it's got two terms. Monomials just have one term. Okay, polynomials have two terms, x plus 1, two terms. A trinomial, x squared plus 4x plus 4, it has three terms. Okay, so three terms. And then a polynomial with more than three terms, you just call it a polynomial. So when you're doing with a one term, you just do regular division because it's just one term. I'm going to show you how you can do long division with polynomials where they have more than two terms, okay? Or more than one term, rather, more than one term. So let's look at this one. We want to divide x squared plus 14x plus 45, and we want to divide that by x plus 9, okay? We're going to divide our quotient, not our quotient, our dividend is this, and the person doing the dividing is this, okay? So we're looking for the quotient and looking for the remainder, okay? That's what we're looking for. But before we do that, one of the things I want to point out, so we're going to write this exactly like we would a long division problem. So let me see, I can do blue. So we're going to have x squared plus 14x plus 45, and that's divided by x plus 9. One of the things that you want to make sure that you do, make sure that your polynomial that's under here, that it's descending power in order. Make sure you're going from x squared to x to no x. If it's x cubed, you want to go x cubed, x squared, x to no x, or I'll put 0. So you want to make sure that it's in order by descending power. If one happens to be missing, you would just put a 0. So like, for example, let's say this was x squared plus 45. You would write it as x squared plus 0x plus 45, because you want to make sure when you're doing the division, you're combining the right terms. You want to combine like terms. So if you fill in the missing place values with 0, that'll help keep everything lined up. Okay, and I'll show you, I'll do an example of that so you can see what that looks like. Okay, so just like we did with long division, look at this one. You're gonna focus on this first term, okay? Don't worry about that for now. You're gonna focus on the first term here. And you're gonna say, okay, what do I need to multiply to this x to get x squared? Well, x times x is x squared, right? So I'm gonna put an x here, and I'm gonna say x times x times x is x squared. Okay, so that gives me x squared. And then x times the 9 gives me 9x. So that's going to be plus 9x. So you see what I was saying about filling in, keeping your terms lined up, because when we do the subtraction, you got to make sure you're subtracting the right terms, combining like terms, okay? So that's where that comes into play. So now you subtract everything, and that means everybody gets subtracted. So what I teach people to do, the 9x is going to get subtracted and the x squared is going to get subtracted. So I put my negative right next to it so I can make sure that everybody gets subtracted, okay? Because when we were doing the long division, you subtracted that number. You subtracted all the numbers underneath. It's going to be the same thing here. Everybody has to get subtracted, okay? So then you say, okay, x squared minus x squared, we know that's 0, right? And then you have a 14x, you have a 14x minus the 9x. 14x minus the 9x. Notice I'm just going straight down, just straight down. Okay, so then 14x minus 9x, that gives me what? 5x? I'll go ahead and put it right here. That gives me 5x, and then I need to bring down my 45. So that's 5x plus 45. You see that? 5x plus 45. And now you're like, okay, then what? Then you say, okay, look at this term. And you say, okay, what times this x will give me 5x? Well, 5, right? And it's a positive 5. So we're going to say plus 5. And we're going to say, okay, 5 times x gives me what? 5x. And then 5 times the 9 is going to give me 45. Y'all see that? So, okay, so 5 times the x, 5x. And then 5 times the 9, 45. Everybody gets subtracted. Everybody gets subtracted. Okay, so then 5x minus 5x, that's going to be 0. And then 45 and negative 45, that's going to be 0. So if you notice here, we end up with 0. This is our remainder. So what does that mean? What does that mean? That means that x plus 5 is a factor, right, of x squared plus 14x plus 45. This also means that x plus 9 is also a factor of x squared plus 14x plus 45, which we already knew that, right? We already knew that because when we learned how to do factoring, what we did, we would take this polynomial and we would factor it, right? We would say x squared plus 14x plus 45, and we would factor it. We would say, okay, what would go in there? We did the full method backwards, right? and we say, okay, well, the x times the x gives me x squared. And then we said, okay, what two numbers that if I add them, I get the 14x, and if I multiply them, I get 45. I did a video on factoring. I will make sure to post it in the description so that you can recognize this part here, okay? So let's continue. So this would be what? 5x and a 9x, and then a 5 times 9. And you would have, okay, plus 5, and you would have plus 9. So I picked one that we already knew how to factor so that you could see, yeah, these are factors. And because they're factors, we're going to get a remainder of 0. And then we also learned that these right here, these are also x equals -5 and x equals -9. When you set those equal to zeros, those become I'm sorry, when you set, let me show you which part I'm talking about. When you set these equal to 0 and solve for x, you end up finding the x-intercepts. So yes, your factors, when you do the division and your remainder is 0, they're also x-intercepts. So when you graph them, those would be your x-intercept points, okay? If you've been following the lesson, you're going to see how all this fits together, okay? It's pretty slick, pretty slick. All right, let's look at this one. 11, oh, 7. I skipped the whole 7. 7 minus 11x minus 3x squared plus 2x cubed, and we want to divide that by x minus 3. So again, this right here, this is your dividend, right? This is your divisor. We're looking for the quotient, and then we're looking for the remainder. If we get a remainder of 0, that means this is a factor of this entire polynomial. And if it's a factor, that means when we graph it, this becomes, the positive 3 becomes an x-intercept. So let's go through it, right? Let's go through it. So let me write it down. Now, I told you, I put a little star here so we don't forget. Write this in descending power order. So it should be the 2x cubed first, then the minus 3x squared, then the minus 11x, then the 7. Because when you start doing the division, you want everything to line up. So let me write it in the, so we have 2x cubed, right? Minus 3x squared, minus 11x, and then plus 7. Notice I kept the signs. See, I kept the signs with those numbers. Okay, and that's going to be divided by x minus 3. So far, so good? So again, look at the first term. We're looking at this 2x cubed. Okay, what times this x will give me 2x cubed? Well, 2, I need a 2, right? I need a 2, and I need an x, probably an x squared. Why do I need an x squared? Because 2x squared times one more x gives me 2x to the third. That gives me my 3x's, right? You see that? So then now 2x squared, that gives me 2x, get my brown. That gives me 2x cubed, right? Draw my line. Everybody gets subtracted. When I subtract that, I get 0, right? So now let's bring, oh, hold on. Let's keep going. I did 2x cubed times the x. See, you got to slow down. That gives you the minus 2x cubed. But then 2x cubed times the minus 3. That gives me a what? A minus 6, because 2 times 3 is 6. X squared. Now I can do that. And then remember, everybody gets subtracted. Everybody gets subtracted. Everybody gets subtracted. Everybody gets subtracted. So I added my little subtraction. Now let's do the math. So 2x cubed minus 2x cubed, that's going to be 0. This is a minus 3x squared minus a minus 6x. I'm saying this, a minus 3x squared minus a negative 6x squared. So these are going to turn into a plus. So you really have a minus 3x squared plus a 6x squared. And we know that's just going to be 3x squared because you're subtracting them. Okay. So then I'm going to put a minus 3 positive 3x squared. I said that too fast, didn't I? Let me write that again so you can see that, because I don't want to say it too fast. Minus 3x squared minus a negative 6x squared. So that's going to be a minus 3x squared, a minus next to and a negative, that becomes a plus. So this is what we're looking at. So that's really 6x squared minus 3x squared. So we're going to have a positive 3x squared. So this is going to be 3x squared. Y'all see that? Okay, and then bring down this guy. Bring down along with the sign too. So that's going to be a minus 11x. Okay, now sorry, here, this times x will give me the 3x squared. What times x will give me 3x squared? Well, I'm going to need a 3 and I'm going to need another x because 3x times x will give me 3x squared, right? Okay, cool beans. So that's going to be a plus 3x squared. And you're like, Dr. B, how do you know that's a plus 3x squared? Because it's positive here. I'm trying to get this value here, okay? So 3x squared times x, that's going to give me 3x squared. And 3x squared times a minus 3. 3x squared times a minus 3 is going to give me a minus 9x squared. A minus 9x squared. So far, so good. Everybody gets subtracted. Everybody gets subtracted. And then, so everybody gets subtracted. So then we have 3x squared minus 3x squared. We know that's 0. We have a minus 11x minus a negative 11x squared. We have a minus 11x minus a negative 9x squared. So that's a minus 11x. That's going to be a plus 9x squared. Y'all see that? Because a minus next to a minus next to a negative, it turns positive. So that's going to give us a minus 2x squared. Back up, back up, back up, back up, back up, back up. Ain't nobody said nothing. Look what I did. 3x squared times that gives me a minus 9x squared. 3x squared times x is 3x cubed. Y'all see that? We don't want that. What do we want? Yep. Back up, back up, back up. I don't mind y'all seeing me mess up because I want y'all to see how easy it is to really be going and miss the signs. So let's back up. Not a problem. Let's back up. Now we're here. Okay. We subtracted this and we ended up with a positive 3x squared, right? Positive 3x squared. So far, so good. And then we brought down our minus 11x. So far, so good. Now we're like, okay, what times x gives me 3x squared? 3x. Not 3x squared, y'all. 3x. What times x gives me 3x squared? That's going to be a 3x. And why is it a positive 3x? Because this is positive. Okay? So now 3x times 3x times x, 3x squared, and then 3x times the minus 3 is going to be a minus 9x, right? Okay. 3x times x, 3x squared. 3x times a minus 3, that's going to give me a minus 9x. And the reason why I knew that was off, because remember I told you, you're combining like terms. So x's go with x's, x squared goes with x squared. Okay, cool beans. So now everybody gets subtracted, right? Everybody gets subtracted. Everybody gets subtracted. 3x squared minus 3x squared, that's 0. And then we have a minus 11x minus a negative 9x. That's going to be a minus 11x plus 9x because the subtraction next to a negative, you can turn them into positive. So this is going to become a negative 2x. Negative 2x, okay? Negative 2x. So now we have a minus 2x, and we need to bring down our plus 7. So far, so good? Okay. Now, what times x gives me a minus 2x? What times x gives me a minus 2x? A minus 2, right? Okay. Minus 2. So we have minus 2 times x. That's going to give me a minus 2x. And then a minus 2 times the minus 3. That's going to give me a positive 6. Y'all see that? Because a negative 3 times a negative 2 is going to be a positive 6. And then a negative 2 times x is the minus 2x. So this is going to be a minus 2x plus 6. everybody gets subtracted. So if I do a subtraction here and a subtraction here on that first term, you have a minus 2x minus a minus 2x. Remember, that becomes plus, so that's 0 because it's 2x and 2x, right? That becomes 0. And then here you have a 7 plus a negative 6, which is really 7 minus 6, which is just going to be 1. Okay, so that becomes 0. And so we're left with, find my green, we're left with 1. So far, so good. So this is our remainder, right? This is our dividend, the number being divided. Our answer, this is our quotient. And then this is our divisor. So now when they ask you for your answer, depending on what area you're working in, they might ask you just to write the quotient. If they say, give me the quotient, they mean give me the answer. But when you have a remainder, you have to write it a certain way. So let me show you how to do that. Okay, so when you write your answer, you want to follow this. Okay, so you normally write your quotient. Let me show you. It looks similar to that. Let me write that in black, I guess. Yeah. So your answer, it's 2x squared plus 3x minus 2. 2x squared plus 3x minus 2, and you would say plus your remainder, which our remainder was 1, over your divisor, which is x minus 3. So if you were to write your answer, this is how they would want you to write it. Okay, so it's your quotient plus your remainder over your divisor. You can't even see that. So it's your quotient plus your remainder over divisor. I'll just say it out loud. So your quotient, your remainder over your divisor. Okay, that's how they would want you to write your answer. Or if they say just give me the quotient, it would just be that. Okay, now let's do this one. 2x to the fourth minus 7x minus 10 divided by x squared minus 2x. So let me write that. I'll start it right here. 2x to the fourth. Now, fill in your missing positions, right? Fill in your missing positions so that when you do the math, you can combine like terms correctly. I do not have a 0. I do not have an x cubed, so I'm going to put 0. I do not have an x squared, so I'm going to put 0. Y'all see that? I do have an x, and then I do have a constant. And we're dividing that by x squared minus 2x. Y'all see that? So we filled in our missing. That way when we combine like terms, everything lines up. Okay, so now we have, we're going to start here, right? So what times x squared will give me 2x to the fourth? Looks like we need a 2, and we need an x squared, 2x squared, right? So then 2x squared times x squared, 2x squared times x squared, that's going to give me a what? 2x to the fourth. Good. And then a 2x squared times a minus 2x, that's going to give me a minus 4x cubed. Minus 4x cubed. And see, that's why I said you want to fill it in so that you have something, when you're doing the math, you have something to subtract it from. Everybody gets subtracted, right? Everybody gets subtracted. So 2x to the fourth minus 2x to the fourth, that's going to be 0. And then that is 0x cubed minus a negative 4x cubed, which is 0x cubed plus 4x cubed. Because a minus next to a negative, they both turn plus. So that's just going to be 4x cubed. You'll see that? So we got 4x cubed. And we're going to bring down, even though it's a 0, we're still going to bring it down, plus our 0x squared. We're doing that so we can keep our placeholders, okay? So now we have what times x squared will give me 4x cubed. Well, you need a 4 and you need an x, right? Because 4x times the x squared, that gives me 4x cubed. So, and it's a positive, so we need a 4x. So we have 4x times x squared gives me 4x cubed, right? And then a 4x minus a minus 4x times a minus 2x, that's going to be a minus 8x squared. You see that? Okay. So then this is going to be 4x cubed, and then this is going to be a minus 8x squared. And where did the minus come from? Right here. Okay, so we have 4x times a minus 2. Everybody gets subtracted. Everybody gets subtracted. And then we have 4x cubed minus 4x cubed. And then we have 0x squared. So we have 0x squared minus a negative 8x squared. So that's going to be 0x squared plus 8x squared, which is just going to be 8x squared. Okay. So we have 8x squared. Bring down our minus 7. Okay. Bring that down. Now, what times x squared will give me an 8x squared? 8. 8 times x squared, 8x squared, right? So then, and it's positive, so this is going to be 8, not an 8x, just an 8. So 8 times x squared is going to give me 8x squared. And then 8 times minus 2x is going to give me what? A minus 8 times 2 is 16, 16x. Y'all see that? Okay, 8 times x squared, 8x squared, 8 times minus 2, 8 times 2 is 16. So it's going to give me a minus 16x. Very good, very, very good. So this gives me 8x squared, and it's going to be minus a 16x. Everybody gets subtracted. Everybody gets subtracted. 8x squared minus 8x squared. And then here we have a minus 7x minus a negative 16x. Y'all see that? Negative 7x minus a negative 16x. So that's really a minus 7x plus a 16x, because the negative and the positive, which that's just going to give us what? Yeah, a 9x. Okay, cool beans. This is going to be 9x, and then we bring down that minus 10. Now, we know to stop here. Why? We know to stop because if you look at this, this is an x squared. Anything times x squared is going to be a squared. So if I'm looking at this and I'm like, oh, 9, well, 9 times x squared, that's going to be a 9x squared. You can't, you've gone as far as you can go because the power on this is less than the power on that. Okay, so it should be obvious that you can stop. And if we're stopping here, then that means this is my remainder. Okay, so again, this is your dividend. This is your divisor. Your answer, that's your quotient. Your answer is called your quotient. And then we've already labeled this as the remainder. So when we write our answer, it's always quotient. Quotient plus remainder over divisor. Quotient, and I'm going to abbreviate, plus remainder over divisor. That's how we write our answer. So let me write the answer. Okay, so we have our quotient, 2x squared plus 4x plus 8, plus our remainder, 9x minus 10, over our divisor, x squared minus 2x. Now we're like, we didn't get a remainder of 0, but that's okay. This still holds true here. So your dividend is equal to this times this, and you have to add the remainder on it, and it'll work out. So that's how you'll check yourself. Just do this, and then you can check yourself. Okay. All right. Just some algorithms. Don't think you have to really like memorize the terms or anything like that. What you want to focus on is you want to focus on what it's saying, and it's what I literally just said. This helps you check behind yourself. So if you have it says if f of x and d of x are polynomials where d of x is not equal to 0 and the degree of d of x is less than or equal to the degree of f of x, then there exists unique polynomials q of x and r of x such that f of x is equal to d of x times q of x plus r of x. You're probably like, what? It's what we just said. The dividend, what you're dividing, is equal to who's doing the dividing times whatever your quotient is plus the remainder. When we said that what was it? When we said that x squared plus 14, let me write here. When we said that x squared plus 14x plus 45 was equal to x plus 9 times x plus 5, the remainder was 0. So that's essentially what we're saying. We're saying that whatever's doing the being divided is going to be equal to your divisor times the quotient plus the remainder. That's what this division algorithm says. So how do you check yourself? Take the dividend, and then if you say, okay, take whatever's doing the dividing, add it to the answer, the quotient, add the remainder, and when you do all of this, you should end back up. Excuse me. You should end back up with the polynomial that you started with. That's all that means. Okay, so that's how you check yourself. Okay, the remainder, like I said, it'll either be 0 or there'll be a degree that was less than. The last example we did, the degree was less than that, and that's how we knew when to stop. See, this was a 9x squared. That's when we knew we needed to stop. So your remainder will either be 0, which was on the first example we did, or it will be a polynomial with a degree less than what you were dividing, less than who was doing the division. If the remainder is equal to 0, then you would say, okay, the divisor divides evenly into f of x, meaning that polynomial divides the bigger polynomial that you were trying to divide. It just means it divides it evenly. Just like how 8 divides 4 evenly, you're saying the same thing. This polynomial divides this polynomial evenly, and that means that the two numbers that you multiply together, those are factors of x, which that's what we established at the very beginning, okay? Okay. At any time you can ask questions. I want to make sure it makes sense. Now, we were doing long division. There's this thing called synthetic division. It's pretty slick. Long division is just the traditional way that we've always done it. You multiply, you carry, you bring down, subtract. Multiply, carry, bring down, subtract until you get to your remainder. What the cool thing about synthetic division is, you don't have to do all the going down in the tree. All you have to deal with are the coefficients, and you get to add. So remember how we were like subtract everything. Well, with the coefficients, because you're carrying the signs of the coefficients, all you have to do is add. Okay, so I'm going to show you, but there is a catch to it. And this is the part that sometimes students can get confused on, but I'm trying to make it as simple as possible. So you can only use synthetic division when your divisor is a binomial. Remember, a binomial has two terms. It has to be in this form, x minus c. It has to be in that form, x minus c. If it's in this form, x minus c, then you can do synthetic division. Okay, so I'm going to show you, I'm going to pull what we did because this was our first example. I'm going to pull what we did, what it looked like, so we can compare them side by side. Okay, one sec. Okay, so this is on the left. That's the example we did at the very, very beginning when we did long division to show, and you see where we got the remainder of 0. We got the remainder of 0, and that tells us that x plus 9 and x plus 5 are factors of the polynomial underneath. Okay, now when you do synthetic division, you set it up exactly the same. It's not anything special. The only thing is you use the coefficients, and I only can use it if the divisor is of the form x minus c. Okay, only if it's of the form x minus c. Let me show you how to set this up. So what you do, remember I told you we're only dealing with the coefficients. And then this, what I'm dividing by, I need to make it look like that. So right now I have x plus 9, but I need it to be x minus something. Do you agree that if I rewrite this as x minus negative 9, it fits this form here? Y'all see that? So x minus 9, x minus negative 9, it fits that form. So that means my c is equal to -9. Do y'all see that? In order for me to use synthetic division, this has to be written in that form. Right now I have x plus 9, but I need it to be x minus something. Well, in order for it to be the same thing or an equivalent, this has to be a -9. So x plus 9 is really x minus -9. And so this is my C, because I'm making this be in that form. Okay. So what you do is when you write it in synthetic form, you have like your little house here, and then you list all the coefficients. So your C goes here, and then all of your coefficients go here, and then you draw a line and you start doing the math. So let me walk through this and then we'll do some more examples. So my C is -9. Okay, we already talked about y. And then the coefficient on my x squared, that's 1. The coefficient on my 14x term is 14. And then we have 45. So you're only pulling the coefficients, okay? You're only pulling the coefficients, which is 1, 14, and 45. Your C goes here, and then your coefficients go here, okay? Then the first thing you do, you bring this number down, and then you're whatever you get here, you're going to multiply it to the 9, and you're going to put it here. You're going to get an answer, and then you're going to multiply it to the 9. You're going to put it here. Then you're going to get an answer, and then you should know if you should be able to stop or keep going. Now, once you get to the end, you're going to stop. But so you pull down the 1, and then you say 1. You say 1 times -9 is -9, right? Okay, so I'm going to write -9. And then you add 14 plus -9. That's going to give me what, 5? And then you say, okay, 5 times -9, that's -45. And then you say 45 plus -45, that is 0. And since I've gotten to the end of this process, that's my remainder. Now, all you have to do is now convert it back to using variables. So we took all of the numbers so that we could do synthetic division. We put our divisor, we wrote our divisor so it's in that form. So I'm going to put right here that we said C was equal to -9. So now what happens is you start, when you write the answer, you start writing it, this part here, with the degree less than what you started with. So if this is x squared, this row, like this is x squared, 14x, and this is, what do you call it, 9? The constant, sorry, to my 9. The constant. This translates, now you go 1 degree less, so this becomes now your x plus 5 right here. Let me write it like this. So this right here represents x plus 5. This right here represents x x plus 9. That's what that represents. And because I have a remainder of 0, this is my remainder. And because I have a remainder of 0, that means these are factors. I hope that wasn't confusing. All we did, we took the coefficients and they went here. We wrote this in the form of x minus c. Okay, we put the c here. The first number comes down, and then you take 1 times the -9, get -9, and then you add. We said 14 plus -9 was 5. Then we take 5 times the -9, and we got -45. And then we said 45 plus -45 is 0, and we knew that we were done. That is our remainder. And then whatever ends up here, you write it with the next lowest power. If I can say lowest power, you write it with the next power down. Because our dividend started with x squared, this needs to start with x. So it's always going to go down. If our dividend started with x cubed, this would start with an x squared. And then it kind of gives it away because this is a 0. That's your remainder. So then you work backward. Constant x, then x squared, then x cubed for whatever you have. Let's do another one. This one, remember, we got to put these in, let's put them in order. So I'm going to write, this needs to be in the form of x minus c. Is it already in that form? Yes. So that means my c is equal to 3. Okay, my c is equal to 3. I don't have to say plus plus or minus minus anything like that because it's already in that form. And then I'm going to write it in descending power so that I can do the synthetic division, okay? Let me write my dividend. I'm going to write it in descending power order. So that's going to be 2x cubed minus 3x squared minus 11x plus 7, right? 2x cubed minus 3x squared minus 11x plus 7. And now I'm going to put it, here's my little, we said our c was 3. I'm going to write the coefficients. So I have 2, then I have -3, then I have -11, and then I have 7. Okay, 2, -3, -11, and 7. And remember, everybody gets added. If it helps, I can put a plus symbol here. Everybody gets added. So let's get started. We bring down the 2, and we say 2 times 3 is 6. 6, -3 plus 6 is going to give me what? A minus, or a positive 3, rather. And then 3 times the 3, that's 9. -11 plus 9, that's going to be a -2. And then -2 times a positive 3, that's going to be a -6. And then 7 minus 6 just gives me 1. So I know that I'm done. The last spot is always going to be the remainder. Okay, so I'm going to box that. Okay, that's the remainder. And then because my dividend started with a cubed, when I rewrite this, it's going to start with a squared. Okay, so this represents the squared, the x, and then the constant, and then this is your remainder. Okay, so now when I rewrite this, this is going to be, let me not do it, I'm going to do it down here. This is going to be 2x squared plus 3x minus 2, right? And we already know that this, come over here, this is already x minus 3 because that's what we started with, right? So then, and then this is our remainder. So when you write your answer, it's quotient plus remainder over divisor. So 2x squared plus 3x minus 2 plus my remainder of 1 over my divisor, x minus 3. And I believe that's what we got when we did this example the first time. So here's where we did it the first time. See, when we did long division, exact same answer. Okay, so I hope you're confident when you saw that, okay, this is exact same answer, okay? Now you see how synthetic division, it keeps everything right here. All you have to use are the coefficients and your C, and you're good to go. Okay, now look at this one. The first thing, before you even try to set it up, what has to be? This has to be a binomial. It's a binomial, but it has to be in the form of x minus c. Can we put this in the form of x minus c? No, because this is an x squared. Well, you can say, oh, what if I factor? We're not trying to do that right now. We're trying to do simple division. If it looked just had this, we could do it. But because this is an x squared minus 2x, I cannot make it into this form x minus c. I can't do that. Okay, so on this one, I'm just going to write cannot use synthetic division. And you're going to say why? I'm going to say because x squared minus 2x is not in the form of x minus c. And we can't make it. We can't make it. So you cannot use synthetic division on this one. On this one, you would use long division. Now, when we did this example the last time, we used long division. So here's that example when we use long division. See, you can do long division, but you can't do synthetic division. Okay, cannot do synthetic division. Let's look at this next one. Dividing. Okay, okay, we can do this one like that. We can do this one like that. So take a look. Is this in the form of x minus c? No. Can we make it in the form of x minus c? Yes. If I were to rewrite this, it would be x minus a negative 2, because a minus next to that gives me plus, and then they would look the same. So when we're looking at this one, what is our c going to be? Our c is going to be negative 2. Okay, and why? How did I find? Because remember, this has to be in the form of x minus c, and then this is our c. Okay, so that's where that's coming from. So that's my c. My dividend, what's being divided, right? My dividend's what being divided. Descending power order, but fill in what's missing. So x cubed. I do not have an x squared. I do not have an x, but I have a constant. Go ahead and fill it in so that when you set up your synthetic division, you can fill in those place values. Okay, so I'm going to do our little bar here, and then do my line here. Pull only the constants, the coefficients. Sorry, pull only the coefficients. So I have 1x cubed, 0x squared, 0x, and minus 6. So far, so good. And then everybody gets added, right? Of course, right here, this is going to be our remainder. That's going to be the last step. And then everybody gets added. Our c is negative 2. So I'm going to put that there. And now we're going to do the math. So now the first number always comes down, right? So we have 1. 1 times negative 2 is going to give me negative 2. 0 plus negative 2. 0 plus negative 2 is going to be negative 2. Negative 2 times negative 2. Negative 2 times negative 2, that's going to give me 4. Because a negative times a negative will give me a positive. That's going to give me a 4. And then 0 plus 4 is going to be 4, right? And then a 4 times negative 2 is going to give me a negative 8. And then a negative 6 and a minus 8 is a minus 14. My box is too small. Minus 14. And then that's my remainder, right? Yep, that's my remainder. Now if I'm switching back from coefficients to variables, because my dividend started with an x cubed, this needs to now start with an x squared. Okay, so if I were to rewrite this, if I were to rewrite this, this is 1x squared, right? Minus 2x plus 4. So far, so good. We know that this is x plus 2. And its quotient, when we write our answer, it's quotient plus remainder over divisor. Okay, quotient plus remainder over divisor. So x squared minus 2x plus 4 plus remainder over divisor. I don't remember telling y'all that this is the quotient, but down here, or rather this part, this is your quotient. That's your answer, okay? The quotient's the answer. That's probably why I didn't say it. And then, of course, your remainder. And then whoever's doing the dividing, this is your divisor. Okay? Cool beans. Cool beans, cool beans, cool beans. Couple more things. So there's 2 theorems. Now, it's not about you memorizing the theorem unless you absolutely have to memorize it and you have to know it. So it says the remainder theorem, and then we have a factor theorem. You're going to notice that I've already said these things. I'm just giving you the name of what they mean. So the remainder theorem says if I have a polynomial and it's divided by a binomial in the form of x minus c, remember a binomial is just a polynomial with 2 factors, then the remainder is the value of f of c. And you're like, what does that mean? I'm going to show you. The remainder, the number that you end up with as a remainder, is the value of f when you evaluate the polynomial at the value c. If I take that remainder and I plug it into my polynomial, I should get, not the remainder, if I take the c and I plug it into my polynomial, your answer is going to be the same thing as the remainder when you're doing long division. Let me show it to you. I'll show it to you. And then the factor theorem, which we've already said before, the factor theorem states that your polynomial, if you take that c and when you do the division, if your remainder is 0, then it means that that divisor is a factor. We saw that at the very beginning when we had the first example we did, and it ended up being x plus 9 times x plus 5. We knew that those two binomials were factors of the big polynomial because the remainder was 0. That's what this factor theorem says. And then vice versa. If you know that that binomial is a factor, then you automatically know that the remainder is going to be 0. Meaning if I take that value and I plug it into my polynomial, I know I'm going to get 0 as a remainder. So anytime you know that a binomial is the factor of a bigger binomial, you can automatically say that the remainder is going to be 0. And we know when we plug in a value for x into f of x, and when the outcome is 0, that means it's a factor. And that's why we come up with the factor theorem. So let me show you. I'm just going to give you just some small examples so you can see both of these. Again, it's not a matter of memorizing the theorem unless it's something that your professor requires. It's a matter of knowing what's happening. If I take that c and I plug it into f of x, whatever value comes out, that's the what do you call it? Y and f of x are the same thing. So when you graph it, that's the y value is what I'm trying to say. And then if you end up plugging in that c into f of x and the remainder is 0, you have found a factor. And you know if it's a factor, it's a 0, it's an x-intercept. They all go together, okay? They all go together. So let me show you. Let's look at this one. How do we want to do this? How do we want to, you want to do synthetic division or do you want to do long division? I think we should do synthetic division because I think it'll be less work. So this needs to be in the form of x minus c. How do I make it in the form of x minus c? This needs to be x minus a negative 4. You see that? And then that's going to be my c value. So here I'm going to put my c is negative 4. Here's my dividend. My dividend is the polynomial being divided. It's 3x cubed plus 4x squared minus 5x plus 3. There's no missing values that I need to fill in. It's already going in descending power order, so that's good. So let's do synthetic division. We said our c was negative 4, right? And then we have 3, 4, minus 5, and then 3. We know our remainder is always going to be whatever the last thing is. Last time I wrote it too small. Okay, and everybody gets added when we do synthetic division. Okay, first step is to bring down the 3. 3 times negative 4 is going to give me a minus 12, right? 3 times negative 4 is going to give me a negative 12. And then 4 plus negative 12, that's going to be what? A negative 8. And then 8 times negative 8 times negative 4 is going to be what? 32. Negative 8 times negative 4, that's going to be a positive 32, right? And then a negative 5 plus a 32, what is that, 5, 6? Okay, that's going to be what, 27? 27. Okay, and then 27 times negative 4, that should be 108, I think. 27 times negative 4. Yeah, that's going to be 108. And then 3 plus 108, negative. Yeah, sorry. Let me show you. 27 times negative 4, that's going to be a negative 108. A negative 108. And then 3 plus negative 108 is going to be a negative 105. Woo! Okay, so what does this mean? The remainder theorem. The remainder theorem says that whatever the remainder value is, it's the value when you evaluate the polynomial at the point C. So if I go back, this means that if I were to write it, this means that f, because this is f of x here, let me write that. This is f of x. This means f of x evaluated at -4 is equal to -105. That's what that means. This is based on the remainder theorem. That's what it means. If I take the c value and I plug it into my polynomial, the answer I should get is -105. Do we want to see that happen? Yeah, well, let's see it so you can, I think if you can see it, you'll be like, oh, okay, that makes sense. Okay, again, so we're saying that the remainder theorem tells us that the function, the polynomial function evaluated at this c value is going to be, the answer is going to be 105. That's what it means. So that means, let me show you. So if this is f of x, which we know that it is 3x cubed plus 4x squared minus 5x plus 3, that's what it is. Then that means if I take this and I evaluate it at -4, that means take every x value and substitute -4. Okay, so far so good? Okay, let's keep going. So then this is going to be 3 times, what is that, -64 plus 4 times 16 minus 5 times a -4 is going to be a -20. So I'll go ahead and put -20 here, and then plus 3, right? And then 3 times -64, that's going to be a negative, I believe, 192. And then 4 times 16, that's going to be 64. And then a negative next to a negative, that's going to be a plus, right? So that's going to be plus 20, and then plus 3. And then if you put all of this in your calculator here, so -192 plus 64 plus 20 plus 3, -105. Y'all see that? So everything ties together. Everything ties together, and that's what they're wanting you to see from the remainder theorem. That's what they're wanting you to see. That if you when you do the long division, and you're dividing it by a binomial in this form, if you take that c value and if you plug it in here, it's going to be the same answer as the remainder when you do long division. And this is what we proved here. So we did long division to c. It's not a factor. It's not a factor because this was not 0. Okay, if it's a factor, this would be 0. But this is what you get. Okay, this is what you get. Cool beans. I hope that made sense. Now, the factor of the example of the factor theorem. Remember, it says that if the remainder is 0, then that means you can evaluate f at that value, and it would also be a factor, or vice versa. You know that x plus 5 is a factor because when I evaluate the dividend at -5, I get 0. Now you're saying, where am I getting that from? Remember, this has to be in the form of x minus c. So this could be x minus -5. So my c on this one would be -5, right? And then my dividend, what's being divided, and I'll go ahead and write it with the f of x. X squared plus 14x plus 45. Now you're like, Dr. B, we already did this one. We did this one 1,000 times when we did synthetic division. I know, but we're gonna do it again. Okay. So it won't take long because we already know what it is. So this I'll put the -5 here. Okay, and then I have, what is that? 1, because nothing's missing, right? Yeah, nothing's missing. 1, 14, and 45. When we did this one, we knew that -5 was a 0. And then I'm going to go ahead and I'm going to kind of cheat here. And I'm going to put -9. Because remember, we knew when this is factored, this is x plus 5 times x plus 9. We know they're factors, but I just want to prove it to you doing the synthetic division. Okay, so we have 1, we have 14, and then we have 45. We know our remainder goes here, right? Okay. this number goes down, and I'm doing it because I want you to see these numbers come down. Okay, so that brings a 1. 1 times -5 is going to be -5. 14 plus 14 plus -5, that's going to give me what? A 9. And then 9 times -5 is going to be a -45. And we know that 45 plus 45 is going to be 0. And when we write this, we go down a level. So if my dividend starts with x squared, this needs to start with x. So when I rewrite this, this is going to be x plus 9, right? And when this is written, we know that this is x plus 5. We know that because that's what we started with. That's what we started with. Okay, same thing here. Bring down the 1. 1 times -9, that's going to be -9. 14 plus -9, that's going to be 5. 5 times -9, that's going to be a -45, right? -45. And then -45 plus 5, that's going to be 0. Because this started as a squared, this is going to come down a level. So this is going to be written as x plus 5. And we know that this is x plus 9. We know they're factors because we did that at the very beginning. And the factor theorem says that if you end up with a remainder of 0, that means that this is a factor of that polynomial. This is also a factor of that polynomial. Okay, and we proved that this was a factor because when we did synthetic division, we got 0. And we proved that this is a factor because when we got synthetic division, we got 0. That's what that factor theorem says. See? And vice versa. Okay, that's what we prove. And then if I were to graph this, if they're factors, they're x-intercepts. If they're factors and you get 0, they're x-intercepts. See? These are the factors, right? So that means if I take -5 and I plug it into this polynomial, if I get 0, that's the point -5, 0, which is here on the graph. Y'all see that? So that's how these pieces fit together. Same thing, -9. If I take -9 and I plug it into this function, I end up with 0. So that means when x is -9, f of x, which is the same thing as y, remember y is the same thing as f of x. When you're talking about functions, you just write it this way, okay? You get -9, which is right here, right next to the 10. So this is the point -5, 0. This is the point -9, 0. Okay, they are factors. They are factors. Because they're factors and the remainder was 0, they're also x-intercepts. So your x-intercepts, your factors, your zeros, those are your solutions. They all fit together, okay? Send me your questions. So common mistakes when you're dividing polynomials. Not understanding what the factor is, but you do now. Not knowing foundational long division. Just practice. It's going to come back to you. Make sure you write the powers in descending order. So cubed, squared, x, constant, fifth, 4, 3, 2, 1. It's got to go in descending power before you start doing the dividing. If you're missing any placeholders, like if there's no x cubed, there's no x squared, put 0x cubed, 0x squared. You'll know that you're missing it because you're going to start doing the long division and you're going to be like, I don't have a common term. I don't have like terms. Go back and make sure you've put in a 0 for the placeholder. Synthetic division only works when the divisor is of the form x minus c. So if it says x plus 4, you need to rewrite it as x minus -4 so that you can get it. But if it already says x minus 2, then your c is going to be the 2, okay? Always check behind yourself. Key takeaways. Okay, you know how to divide now. You know how to divide polynomials. Now, if you've been following the lesson stream, you know how to add, subtract, multiply, and now divide polynomials. Congratulations. You can use long division every time. Every single time you can use long division. There are no special rules. You know when to use synthetic division. You only can use synthetic division when the binomial is of the form x minus c. Okay, that's when you can use synthetic division. You know how to write your answers now. If they ask for the quotient, if they say give me the quotient, they're basically say give me the answer. Just give them the quotient. But if they tell you to write your answer is in the form of quotient plus remainder over divisor, That's what we did on all of our examples. So you might have to rewind and go back and look at some of those. Follow the steps and watch your signs. Remember, with the long division, everybody gets subtracted. So if it helps to put the subtraction next to everybody, put the subtraction next to every term. On synthetic division, everybody gets added, and it's kind of easier because all you have to do is focus on top, bottom. Add, add, add. But watch your signs, fill in your placeholders. Don't forget to check behind yourself. So you should be able to complete your assignment with success, okay? Remember, some questions that you do on your homework may be harder, it may be easier. Follow the steps that we did in this lesson, and I believe very strongly that you're going to get everything right. Take your time, follow the signs, write things down so that you can see them. It's easy to spit things out of your mind, but when you put it on paper, it definitely helps your mind to absorb it all. Keep it. Look, no shame, no shame. Keep your calculator handy. If you're working on your multiplication, if you're still working on your division, if you're still trying to figure out factoring, keep your calculator handy. And remember, at any point during my videos or whenever, you can leave me a comment. You can reach out to me because I am always ready to help you. Okay? All right, y'all. See ya. Bye-bye.